So the next numerical on nuclear physics unit 1, that is atoms and nuclei, for class 12th is calculate the velocity of electron in Bohr's first orbit of hydrogen atom, and how many times does the electron go in Bohr's first orbit in 1 second. So basically, before approaching this type of question, I will consider you to go to the videos which I have provided in my playlist in my channel, then come to solve the numericals. And the reason behind is that you're gonna learn each and every single thing about these all experiments. Like this question is based on Bohr's atomic model, and you can find it very useful in my previous videos. So we are going to use here the formula of velocity, because we have calculated the orbital velocity of hydrogen atom. Okay, for the first orbit of hydrogen atom in our previous videos. So we have a formula, V is equals to 2 pi k z e square upon nh. Okay, so here we are given in the question velocity of electron in first orbit. This we have to find out. Okay, we have to find out velocity and frequency also. Okay, frequency, how we are getting that, we have to find out the frequency. Read the question again. That question says how many times does the electron goes in Bohr's first orbit in 1 second. So what is frequency? Frequency is related to this only. Okay, so that's why we are getting that we have to calculate the frequency here. So using the formula of Bohr's orbital velocity of hydrogen atom, orbital velocity of electron in the first orbit of hydrogen atom is V is equals to 2 pi k z e square upon nh. So for first orbit of hydrogen atom, we have atomic number of hydrogen is 1, and first orbit, that is n, is equals to 1. Now we are going to put all the values in this formula. So V is equals to 2 pi is 3.14, k is nothing but 9 into 10 to the power 9, that is dielectric constant. The value of 1 upon 4 pi epsilon naught is equals to k, which is equals to 9 into 10 to the power 9. Here you can say this. Okay, so now what again we have to put the value of this electron, that is 1.6 into 10 to the power minus 19 square upon h, because n is equals to 1, so only h will be here. So the value of h is, this is Planck's constant, its value is 6.63 into 10 to the power minus times 34. Okay, so after solving all these, okay, you can calculate by yourself, so that your calculation will be nice, just for practice. So you're gonna have the value 21.8 into 10 to the power minus 5 meter per second. Now to write in significant figures, we are shifting a point. Okay, so we are going to write it as 2.18 into 10 to the power 6, because 1 power will be increased if we will shift the point. So meter second inverse. Now again, what in the significance figure, we are going to write it as round of figures, so it will become 2.2 into 10 to the power 6 meter per second. Okay, so this is, now we have to find out the frequency, because velocity we have find out, and we have velocity is equals to 2.2 into 10 to the power 6 meter per second. We know that unit of velocity is meter per second. Now we have to find out the frequency. Frequency is, we know that reciprocal of time period, so time period, that is 1 upon t. Okay, so formula of t is 2 pi r upon v. So इसे हम rearrange करेंगे तो हमारे पास बनेगा v upon 2 pi r. Okay, v is the velocity and r is the radius of first orbit of hydrogen atom from the nucleus. Okay, न्यूक्लियस से हाइड्रोजन एटम की पहले ऑर्बिट की जो रेडियस है उसे r से डिनोट किया हुआ है यहाँ पर हमने, और ठीक है, तो फिर अब हमारे पास क्या आया यहाँ पे 2.18, दैट इज़ वेलोसिटी की वैल्यू हमारे पास है 2.18 इंटू 10 टू द पावर 6, और 2 पाई आर 2 इंटू 3.14 इंटू 0.53 इंटू 10 टू द पावर माइनस 10. ठीक है, और हमें पता है फ्रीक्वेंसी की यूनिट होती है हमारी हर्ट्स, तो इसलिए इसे कैलकुलेट करने के बाद जो भी वैल्यू है उसे हमने लिखा हर्ट्स में. अब इसे हमने क्या करना है, सिग्निफिकेंट फिगर्स में लिखना है, तो इसे हमने लिख लिया 6.54 इंटू 10 टू द पावर 15 हर्ट्स. ओके, सो आई होप कि आपको ये क्वेश्चन समझ में आया होगा. ठीक है, तो नेक्स्ट क्वेश्चन हम करेंगे अपनी नेक्स्ट वीडियो में. थैंक यू.